AWS API Gateway is basically the intelligent front door and the grand orchestrator for your serverless backend. It takes raw HTTP requests and transforms them into beautifully structured events. Think of it as the ultimate air traffic controller for your data. It takes the totally chaotic, unpredictable nature of the open internet and meticulously translates it into a precise language that your internal systems can actually understand and process without completely crashing. It's really the definitive mechanism for mastering serverless scale, turning all that potential chaos into managed, reliable infrastructure. So, by definition, it's a fully managed service that intercepts, translates, and orchestrates those messy, raw HTTP requests into structured JSON payloads. And that specific translation, that is exactly what makes it perfectly safe for your serverless backends to process. Without this intermediary sitting in the middle, your backend is entirely exposed to whatever wild formatting and volume the internet decides to throw at it. But to truly understand why this is an absolute necessity, we first have to look at what happens when unmanaged, infinite scale hits a system that doesn't have this protective barrier. Picture this: a sudden 10,000 user spike hits, instantly spinning up parallel executions in your serverless architecture. This creates a massive volumetric flood. And this introduces a pretty lethal reality. The very infinite scale that makes serverless computing, like AWS Lambda, so incredibly powerful, can actually weaponize your own front end. It turns it into a massive DDoS attack against your own downstream legacy systems. Infinite scale is really only a blessing if your older, slower, deeply entrenched relational databases can actually survive the sheer volume of that flood. And, well, more often than not, they just melt under the pressure. To build a gatekeeper that actually prevents that kind of meltdown, we have to choose between heavyweight, feature-rich REST APIs and modern HTTP APIs. The enterprise verdict here gives us a massive financial and performance advantage. For modern microservices, HTTP APIs are significantly faster and up to 71% cheaper because they strip away a lot of the legacy management bloat and just focus on lean, rapid routing. They've overwhelmingly become the enterprise standard for new deployments. It's all about doing exactly what's needed with absolute maximum efficiency. Once you've got it established, the gateway utilizes a proxy integration mechanism that acts exactly like a professional translator at the United Nations. It effortlessly takes a raw, messy HTTP packet, instantly packages it into a comprehensive, standardized JSON object, and then transparently delivers it right to the backend. It's a seamless bridge between the chaotic internet and your highly structured code. This ensures the recipient Lambda function only ever receives data in the exact, pristine format it expects to read. Now, the physical placement of this gateway is just as critical. It requires a really careful architectural choice that's tailored directly to your user base. You might go with global edge-optimized networks using CloudFront, which is absolutely perfect for a highly distributed app. Think something like Netflix. Or you could deploy regional endpoints, which are ideal for a localized food delivery service operating in just one city. Alternatively, for highly sensitive internal tools like HR or financial platforms, strictly isolated private VPC routes ensure the gateway remains completely hidden from the public internet entirely. No outside access whatsoever. At the extreme edge of this network sits our security perimeter. It functions exactly like a highly disciplined cyber bouncer. This bouncer ruthlessly rejects malicious or unauthenticated traffic before any backend compute is ever invoked. And right here is where the absolute financial genius of serverless security really shines. Because AWS charges you for compute time, stopping malicious actors right at the gate means you pay absolutely $0 for that unauthorized compute. It's proactive security that actually protects your budget as fiercely as it protects your data. This enforces the absolute, undeniable golden rule of serverless architecture. Never leave a Lambda function exposed directly to the public internet without a bouncer at the door. Doing so is literally the exact equivalent of leaving the keys in the ignition of a running car in a bad neighborhood and just hoping nobody notices. Putting that gateway in front of your compute isn't optional. It's the non-negotiable foundation of any truly resilient and secure system. So the crucial point becomes exactly how we equip that bouncer to make the right decisions. This zero-cost defense is executed through cryptographic verification via Cognito. Think of a JSON Web Token, a JWT, as a VIP wristband. The gateway acts like an optical scanner, natively intercepting and cryptographically verifying that wristband. If the token is fake or expired, boom, the request is dropped immediately. That keeps your actual compute layer completely dormant and totally free until it's officially authorized. Your Lambda function simply sleeps peacefully until the gateway gives it the definitive green light. Now, for more complex scenarios, dedicated Lambda authorizers can inject custom lifecycle hooks. Imagine a user tries to access a highly restricted premium feature. The gateway essentially pauses the main flow and taps a custom Lambda authorizer on the shoulder. This custom function can quickly reach out, maybe check an old legacy database or a third-party identity provider to verify if their subscription is actually paid up. Only then does it return a strict access policy to either open the gate or permanently drop the connection. And by natively integrating AWS WAF directly into these gateway endpoints, we deploy a comprehensive Layer 7 defense shield. Layer 7 attacks are things like vicious SQL injections attempting to corrupt your databases, or targeted bot floods trying to scrape your proprietary data. With this granular IP control natively integrated, malicious traffic simply shatters against the shield long before it can ever invoke or exploit your delicate backend resources. Okay, so with the outer perimeter totally secured against bad actors, we also have to control the sheer flow of legitimate traffic itself. We do this using an automated token bucket algorithm. Think of it as a literal bucket holding a set number of tokens. Every single time a request comes in, it takes a token out. Now, these tokens refill at a steady, manageable rate, but if a massive spike hits and the bucket goes completely empty, the gateway acts as a pressure valve. It instantly returns a 429 too many requests error to protect your downstream systems from an outright meltdown. But what if a data-heavy, read-only endpoint goes massively viral? We don't want to throttle that, we want to serve it. So we simply enable edge caching. This lets us serve tens of thousands of requests instantly for free, invoking the backend database exactly once to populate the cache. The magic of this is truly staggering. Out of a massive 50,000 request spike, 49,999 of them are served directly from the gateway's edge memory. The users get their data instantly, and your database barely has to lift a finger. But here's a big question. What happens when unpredictable traffic spikes outpace even our absolute highest safe throttling limits? This is especially scary for write-heavy operations, where caching doesn't help at all, because thousands of users are trying to submit unique data, like placing an order, at the exact same agonizing second. This introduces the most critical architectural need for safe, high-velocity ingestion techniques to prevent total systemic collapse. We actually solve this terrifying bottleneck by bypassing the Lambda compute layer entirely. We allow API Gateway to natively funnel the massive flood directly into an SQS buffer. Instead of hitting your servers directly, the gateway acts as a giant funnel, catching the chaotic flood of requests and dropping them into a queue. This queue acts as a structured weeding room, safely trickling the data out to your backend processors one by one at a perfectly safe, highly controlled speed. It processes the messages asynchronously without breaking a sweat. As we confidently orchestrate all these complex deployments, we rely heavily on immutable API snapshots and stage variables. An immutable snapshot is just like saving your progress in a video game right before walking into a massive boss fight. If a new code deployment inexplicably crashes in the production environment, you can use stage variables, which act like a massive, instant railroad switch track to instantly revert traffic back to the saved snapshot with absolute zero downtime. We can further contain our operational blast radius using a 90-10 canary release architecture. That term actually comes from coal miners who used literal canaries to detect toxic gas before it harmed the crew. Systematically, we bleed a small 10% portion of real-world traffic to test the new code environment to see if it actually survives. All the while, we fiercely protect the remaining 90%, which represents our core revenue streams on the rock-solid stable version. When the inevitable time finally comes to modernize massive legacy systems hiding behind our gateway, we employ a highly methodical migration approach known as the strangler fig pattern. This fascinating strategy is named after the real-world strangler fig tree. That tree drops seeds into the upper canopy of a host tree, slowly growing its roots downward until it eventually envelops and entirely replaces the original host tree. This pattern ensures we don't ever have to attempt a highly risky overnight rewrite. By configuring the API gateway to seamlessly route specific targeted endpoints, like maybe the payments or inventory API, to the new serverless infrastructure, we can slowly strangle the monolith piece by piece, right alongside legacy servers. The true beauty here is the absolute stealth of the operation. To the end user interacting with the client, the API feels and behaves exactly the same, with zero disruption. Yet underneath, you are entirely ripping out and replacing the foundation, one single function at a time. When we systematically assemble all of these vital components, we construct something truly remarkable. The WAF perimeter defending against malicious actors, the zero-trust identity verification natively blocking unauthenticated requests, the intelligent gateway orchestration dynamically caching read operations, and the asynchronous SQS buffering protecting against catastrophic write floods. Together, they form a single, living, breathing organism. They construct the ultimate serverless citadel, resulting in an impenetrable, infinitely scalable architecture that practically runs itself. So you now have the definitive blueprint for an impenetrable, infinitely scalable architecture. You understand exactly how to throttle chaotic floods, route global traffic flawlessly, and fiercely protect your core computing budget at literally zero cost. The only real question left for you as an architect is, how will you weaponize the incredible threat of infinite scale into your greatest